And here we go again. So we're gonna talk more about graphs of rational functions. We're not actually gonna graph them, we're just gonna do some matching, which requires you to be able to identify your asymptotes. So reminder, if you wanna figure out any vertical asymptotes, you can set your denominator equal to 0, because if there's a location where your denominator's equal to 0, that's where you will have a vertical asymptote. This one, I'm gonna do a little bit of factoring on. And then we're actually going to end up with two vertical asymptotes, one vertical asymptote of x equals 1/2 and one of x equals -3. Horizontal or slant depends on the degree of the two polynomials that are being divided. This is a case where the degree on top is smaller than the degree on bottom, which automatically means y equals 0 is your horizontal asymptote. All right, so steps to identifying the graph of a rational function. You can factor and simplify if possible to identify if you might have any holes instead of asymptotes, and then just kind of find x, y intercepts. We'll do some. All right, so this is the one from the warm-up. So the asymptotes, I won't explain how to find them again, but they're still the same asymptotes. As I'm rewriting here, let's talk about when you have holes in a graph. So this graph won't have any holes in it. That's only going to happen if I can simplify the original and have one of my factors like divide out. This one doesn't simplify. Y-intercept, x value is equal to 0 there. So plug in 0 for x, you'll end up with y equals -1/3. So it'll cross the y-axis at 0, -1/3. For your x-intercept, plug in 0 for your y value, and I guess scroll back up. So solve to see what x values you get. Those will be your x-intercepts. If you multiply both sides by your denominator, you're just going to end up with 0 equals x plus 1, which means you'll end up with an x-intercept of -1. So it'll cross the x-axis at -1, 0. Now we're going to look at our options and do some matching. I'm going to check through my asymptotes first. So if you look at A, looks like it's got the correct asymptotes. So does B, but C does not. It's missing one vertical asymptote. So we know it's not graph C, kind of process of elimination. If we look at our y-intercepts, graph A crosses at 0, -1/3, but graph B crosses at a positive y value, so it's got the wrong y-intercept. So it can't be graph B. So our rational function of those options has to be graph A. Let's look at a few more here. So this one, we'll have to find our asymptotes, set your denominator equal to 0, and you'll have a vertical asymptote of x equals 2. Compare your degrees, top's degree 2, bottom's degree 1. That means we're going to have a slant asymptote. So let's actually divide to figure out the equation of our slant asymptote. We can do some synthetic division. When you divide, you end up with x plus 2 and then remainder of 5, but only the x plus 2 is going to influence your equation of your slant asymptote. So y equals x plus 2 is your slant asymptote. So there aren't any holes because, again, I couldn't simplify the original and divide out any factors. Y-intercept, plug in 0, you're going to get y value of -1/2, so it'll cross at 0, -1/2. And x-intercept, plug in 0 for y so that it equal to 0. Multiply by x minus 2, you'll just end up with 0 equals x squared plus 1. If you solve, you actually get positive and negative I, which those aren't real numbers, so there are no real numbers where it's going to cross the x-intercept. So no x-intercepts that we can see. All right, so I would look at asymptotes to start with. Graph A looks like it could have the right y-intercept, but that's a negative slope, so that slant asymptote is wrong. Can't be graph A. Graph B, asymptotes look okay, I think. You kind of have to check your scale on your y-axis there. But yeah, looks like your asymptotes are fine. Y-intercept and x-intercepts, though, are incorrect. Oops, I wrote should, but it should be shouldn't cross the x-axis. It shouldn't cross the x-axis, and it has a wrong y-intercept, so it can't be graph B. Make sure graph C looks okay. Hey, maybe there's a none of the above option. Graph C looks fine. Getting a little more complicated in our equation of our rational function here. I'm actually going to do some simplifying to start with because it looks like I could factor and potentially simplify, or at least it'll make it easier to figure out your vertical asymptotes. So if you factors into 3 times x minus 2 and x plus 1, and then the denominator's 2 factors of x plus 4. So since we factored the denominator, we can tell that our vertical asymptote's going to happen at the vertical line x equals -4. Horizontal, it's actually, or slant potentially, it's actually easiest to look at the original. The degrees are the same of your numerator and denominator, so it'll be a horizontal asymptote where I divide my leading coefficients to figure out my equation of my line. So I'll have a horizontal asymptote. If you take your 3x squared divided by x squared, you just get a horizontal asymptote of 3. No holes again. Y-intercept, plug in 0 for all of your x's, and you'll end up with -6/16, which simplifies to -3/8. And last but not least, your x-intercept, set it equal to 0. I'm just going to copy and paste. Should have done that on some earlier. All right, so if you multiply by your x plus 4s, you still get 0 equals your numerator. This time you're going to have 2 x-intercepts, 2 and -1, so there will be 2 points where it crosses your x-axis. Let's see what we can figure out here. So graph A, vertical asymptotes and horizontal look okay. Graph B and C, all the asymptotes are actually 100% all right on these. A little harder to narrow down. If you look at your x-intercepts, though, it's supposed to cross the x-axis at 2 and -1, and graph A does not. So let's cross out graph A because it has no x-intercepts. Graphs B and C, they both have, it looks like, potentially okay x-intercepts and y-intercepts. So let's try plugging in a point. Let's do x equals 3 and compare it to our 2 graphs. If you plug in 3 for your x value, I'm doing it into the factored version. You could do it into the original. You're going to end up with, work this out here, 12/49. Well, if you look at graph B, looks like that could be the point, 3, 12/49. So graph C is below the y-axis, so it can't be graph C. So it's got to be graph B. One more. Okay, let's talk about one that might have a hole in it. So if you simplify this to start with, you can factor x squared minus 4 into x plus 2 and x minus 2, and then your factors of x minus 2 divide out. So really, since you no longer have a problem at x equals 2, there's a hole there, not an asymptote. There are no asymptotes, since my denominator divided out to 1, but there is, as I said, a hole there at x equals 2. Y-intercept, if you plug 0 in, we'll just do it to my simplified version, you'll get a y-intercept of 2, so it's going to cross the y-axis at 2. X-intercept, plug in 0 for y, solve, should cross the x-axis at -2. So if I look at my options here, first off, graph A has its hole in the wrong spot, so it's not graph A. Graph B, hole at 2, y-intercept of 2, x-intercept of -2, that looks right. Let's check C. Oh, it's got a vertical asymptote, so that's a no. Graph B it is.